the formula sheet that about it, some of the handbook and some have to. I'll tell you by module, like your first module, analog electronics, and in that you will have first chapter, that is diode, correct? So in the diode will have form diode current diode current, and that is denoted by ID. So what is the formula for ID? ID is I the minus 1. Okay. So what is I naught of here? I naught is the reverse current. Sometimes they called it also as edge current. So don't get E is the applied voltage across the diode. How much voltage we have applied across the diode? Theta is constant basically, and EM and E for silicon, and V thermal voltage, that is 1 where we have to convert the temperature Celsius Kelvin only, the Kelvin only. Okay. ID is what? ID is the diode current. How much is cross diode? So as you know, and this part is cathode. So anode must then in that case only current will flow, and that is the case of forward, right? So now for forward bias, if they said there is a large forward bias, in that case you have to use the ID I now raised power by eta. But if they said that there is a case of reverse bias means anode is connected with negative and cathode positive, vice versa, and in this case no current bias. So for this the bias I equal to equal minus I naught. Now generally Manipal they'll give you the question temperature, right? Whenever they set ki do temperature like this one and this one, then in that case you need to have I02 is equal to I1 raised to power. It is 2 raised power, not multiplication. 1 divided by 10. Divided by 10 is only on the raised to the power wali term mein. What is I01 over here? That is the reverse saturation current at T1. What is I02 over here? Reverse saturation current at, right? So here must then, okay. So for generally you have to learn this statement also, that for every 10-degree rise in temperature there is a double in the saturation current. Okay. Now after this related to diode only, they'll ask you, multiple people sometime ask the dynamic resistance, and they'll ask you for the static resistance, right? Static resistance is a kind of which there is no voltage current, correct? So dynamic resistance means will be changed, there can be change. Static resistance by R, that is by ID. ID is diode current equation, and the applied voltage. Okay. And dynamic resistance is RD is equal to, it is basically shown that dynamic is R only the divided by ID plus I naught. Okay. So it's a resistance, so it's Whenever they set static resistance, then in that case you need to calculate ID. Now where the generally students feel ID को solve करने problem, so it's better to take ID by I naught, then e raised to power this term, right? Then take log both side. Okay, we'll take log both side, then log e is always equal to 1, so e will be eliminated. So generally students को ये problem आती है. Okay, next is Zener diode. In Zener diode we have one thing, one is regulation, one is load regulation. uh Sometimes they'll ask you this, so I told you the difference. Line regulation if input voltage is varying, load regulation if load resistance is varying. So in both the cases output voltage constant, right? If input voltage is varying, supply current should also vary, and if supply current is varying and load current must be constant, so that IZ varying. Similar for this case, so this you need to correct. Next, in the Zener diode, I told you that we'll have two conditions. One, either VL, one is Z is less. So if we'll have this condition applicable, so all you need to write down, or this is the first condition, तो सारे formulas यही होंगे. This is the second condition, this all formulas to remember, right? I told you about it कि VZ is more, current is less. Current is less means the diode will behave as open. In this case IZ is 0. If IZ Zener current is 0, then the total current would be the load current. And how will we check that whether we are having VZ is greater than VL or VZ is less than VL? By using this form, right? If every value is given, then we have to use this condition. If no value, like हमें लग रहा है कि if any value is missing, then every time you need to use second. So whenever you feel confused कौन सी condition use करनी है, go for the second condition. Okay, 80% of the time Manipal people give you the question of minimum and maximum. Okay, so minimum and maximum they'll give it to you, so then in that case you have to use second condition. Here I wrote it all the formulas of Zener. Okay, after this you will have rectifier के formulas that were, because in your handbook no formula unrelated to rectifier. So in the rectifier you will have half wave rectifier MWR, and you will have full wave rectifier. In the full wave rectifier you will have step that I'll denoted by CT and you will have bridge type rectifier that I'll denoted by B. Okay, BT bridge type and CT is center type. Now first they'll ask you the generally the IDC. Okay, IDC बोल लो या फिर they can say कि output current, as you know rectifier converts AC, so output current will be DC, or sometime they'll always say कि average value of current. Okay, so average value of current is also IDC only, don't get confused. Namet is same. For half wave rectifier it is Imax by pi, for center tap it is 2 Imax by pi, and for this one also 2 Imax by pi. Now some students ask from me, ma'am, ki no bridge is mentioned. If they have mentioned only full wave rectifier, then we have to use center tap formula या bridge type. Then in that case you have to use bridge type वाला form. ठीक है? If they just mention कि full wave rectifier but they didn't mention कौन सा है, then you have to follow bridge type rectifier form. Next, sometime they'll ask you IRMS. IRMS means the root pair. For this the formula is Imax by 2. For center tap it is Imax by root 2. Again for the full wave it is common, basically Imax by root 2. Next time they can ask the peak inverse voltage. Inverse voltage is the maximum voltage, PIV, that is stands for inverse voltage, and formula for that one is yes maximum. Only in this case it is difference to VS maximum and VS maximum. Okay, ओनली ये वाला डिफरेंट है सेंटर टैप में. ठीक है, ऐसा क्यों है? बिकॉज सेंटर टैप इज सेंटर में टैपिंग होती है एंड इन द सेंटर वी हैव कनेक्टेड विद द ट्रांसफॉर्मर. ऊपर की वी एस मैक्स एंड नीचे की वी एस मैक्स, That's how it become. Next one is sometimes they'll ask you VC, तो VC as you know एक स्टैंडर्ड फॉर्मूला होता है क्या, IDC टू RL. तो IDC तुम्हारे पास ऊपर से आ जाएगा, RL यू ऑलरेडी नो अबाउट इट, राइट, so you can get VD. तो इसलिए VDC का सेपरेट you don't need to remember. ठीक है. नेक्स्ट इज सिमिलरली दे कैन आस्क यू Vmax. तो Vmax का what is Vmax? V equal to Imax RL. Similarly, maybe they'll ask for that VRMS. VRMS is how much? That is IRMS into RL. तो इनका सेपरेट फॉर्मूला याद करने की ज़रूरत नहीं है, ये सारी चीज़ें तुम्हारी यहीं से ही कवर हो गई. करेक्ट. ठीक है. बोलो कोई डाउट यहाँ तक? डाउट अप टू हियर? टेल मी. आफ्टर दैट आई एम rubbing point. After that maximum time they'll ask the efficiency, and that is basically they'll ask you the rectification efficiency. So rectification efficiency for half wave rectifier it is 40.6%, for full wave it is 81.2%. Yeah, but now we need to learn the formula also. What is the formula for that? That is it is 0.406 divided by 1 plus RF by RL. Yeah, अगर RF is given, तो RF is I told you that is the free wheeling diode का resistance, तो वैल्यू चेंज कर जाएगी 40.6. if RF is not given then you can solve it, you will get the same 40.6. for this one it is 0.812 1 plus 2 RF by RL. Okay, similarly this 0.81 divided by 1 plus RF by RL. Got it? Now after that we'll have peak factor, form factor also. Sometime they'll ask you. इससे पहले they'll ask you the ripple factor for half wave and full wave. This is again wave rectifier, wave gap, bridge type, right? So there is a fixed value basically for ripple factor. For half wave rectifier it is 1.2, and for full wave rectifier it is 0.482. So what is the formula for the ripple factor? Write it down. Ripple factor is denoted by gamma. As you can see by Q's, that generally they'll ask you the ripple factor, right? So ripple factor formula is of I, it is the standard formula of IRMS by IDC का होल स्क्वायर माइनस रूट 3 में आएगा. ठीक है. नाउ यू नो कि हाफ वेव रेक्टिफायर में आरएमएस की वैल्यू का और इसका डिफरेंट फॉर्मूला है. तो दिस इज द स्टैंडर्ड फॉर्मूला. तो आईआरएमएस निकालना, आईडीसी निकालना, देन यू विल गेट दिस वन वैल्यू. इट इज नॉट डिफरेंट फॉर हाफ वेव सेंटर टाइप का, ऐसे अलग से याद नहीं करना. इट इज द स्टैंडर्ड फॉर्मूला. और यू कैन यूज कि अगर करंट नहीं निकाल दिया हुआ तो वी आर एम एस बाई वी डी का होल स्क्वायर माइनस 1. ठीक है. So this is the standard formula that is valid for both the cases, half wave and full wave. Efficiency formula I am also telling you direct. Efficiency ka what you can apply, like generally efficiency by V square by R. So देखो basically what is efficiency? That is output power divided by input power, correct? And output power is in the form of DC, input power is in the form of AC. So AC means RMS only. You can say PDC by RMS or PAC, and power का formula you already know, that is V square by R. Okay, V square DC divided by RL. Similarly V square RMS divided by RL. So for if RL would must be cancel out. So you can use this formula also. I'm writing down here, that is V square DC divided by RL divided by V square RMS divided by RL. voltage तो you need to calculate. ठीक है, voltage तुम्हें calculate करनी ही पड़ेगी. Correct? Now after that EDC done, we next and ripple factor, PIV efficiency. हाँ, last but not least output frequency. I'm writing down here output frequency. What is the output frequency? Generally this also they ask. For half wave rectifier it is the same, but for full wave rectifier it is double. I think now also this one. Only you need to learn these formulas 1, 2, 3. So these are the standard formulas तो जो उसी पे ही applicable हो जाएंगे. Next thing is if they'll give you the question of filters. Okay, filters with rectifier. So that case इसी का formula will different होगा. Ripple factor means gamma is this. I think this form for half wave rectifier the formula for VD RL divided by 1 RL multiplied by the maximum. M is the maximum voltage, RL is the load resistance, C stands for capacitor. They'll give you the capacitor value, F stands for frequency. Clearly this 4F RL 1 plus 4 F C RL का क्या हो गया 4 हो गया for full wave rectifier. Similarly ripple factor का formula is by R, that is 1 by 2 F RL. For this one 1 by 4 root F RL. Okay, एक बार ये चेक कर लेना. I think this is now see it का MOSFET important. So MOSFET का will have standard diagram. Okay, that you need to cover it. Well, this one is RD. This one must sometimes they'll give you the voltage over here and the ground. So this is drain terminal, this gate terminal. So यहाँ पे sometime they'll provide you 1 volt and they didn't mention कि which voltage it is. So this is V. ये वाली voltage is V. That is connected between gate and source. Okay, है ना? So this is tricky. So in this you need to remember ID का formula, that is 1 by 2 x W by L bracket Vs minus H का whole square. What is mu and cox? This is the constant. Every time they'll for this नहीं दिया हो तो ये पूरा को k consider कर सकते. K is also constant. But what is W over here? W is the width. L is over here. It is the length. What is VGS? VGS is the gate to voltage. What is VTH? VTH is the threshold. Okay. VDD is the supply voltage basically, and we'll have one this, that if VDS is equal to V minus ID RD. ID is the current, RD is the drain resistance, and Vs is equal to Vs minus. Okay. Only these three formulas you need to remember it for the MOSFET. Okay. Now after this we'll have opamp, right? Analog में will have opamps. As I told you, 2 questions will definitely come from opamp. One is based on CMRR. You have to learn the define of CMRR also. Sometimes they ask you define CMRR, and for the CMRR they you calculate V. What is what? AD V plus AC VC. What is V naught over here? Naught is the output voltage. VD is what? VD is the difference in two voltage, right? So difference in two voltage must be how much? 1 minus, right? AD, A stands for gain, ठीक है, so AD stands for differential gain. What is VC? कई बार VC होता है, कई बार VCM होता है. It is the basically common mode voltage. तो VC का फॉर्मूला इज V1 plus V2 by 2, एवरेज लेते हैं basically. So VCM is V1 plus V2 by 2 and AC is the common mode real नहीं common mode gain, ठीक है. AD is gain, VD is V1 minus V2, C V1 plus V2 by 2, AC is gain, ठीक है. Now see what is the formula for CMRR. Once we calculate AD and AC, then the formula for CMRR is equal to AD by AC only. And if we want to calculate CMRR in decibels, then it would be 20 log of AD by AC. So in some book they said ki AC and in some book they said ACM, common mode gain. Both are same, don't get confused. वो मैम ने तो ये कर, ठीक है, understood. Now after that, next one is opamp, inverting amplifier. You have to remember the derivation of all these amplifier, because sometimes they'll ask you the derivation. So first they'll ask you derivation, then that, then the numerical based on that. So V naught for inverting amplifier, V naught is equal to minus RF by R1 in, if I draw the small, so inverting means positive terminal is grounded, output will have is input resistance by R1 in, correct. Next opamp is non-inverting amplifier. For the non-inverting amplifier, output is V is equal to 1 plus RF by R1 to, diagram for this one is again the opamp, negative here, spec is always connected with the negative, okay, but here non-inverting means voltage must be connected with the positive terminal, so it would be in, this would be out. Next one is voltage follower. वोल्टेज फॉलोवर के केस में आउटपुट वोल्टेज मस्ट इक्वल टू द इनपुट वोल्टेज, and in this case negative positive, this is V in, here there is no resistance in the feedback and in the input also, that's why output voltage is equal to the input. Next one is inverting summing amplifier. Inverting summing amplifier, the formula is not equal to minus RF by R1 V1 minus RF by R2 RF by R3. If I draw the diagram, so I show कि 3 voltage है, तो I am take 3 voltages. Positive terminal is grounded, negative is always connected with the feedback RF. So here we have taken 3 voltage and 1 V3 and R1 R2 R3, ठीक है. After that we'll have summing amplifier के बाद we'll have differential. The difference amplifier, but will have output, you need to remember इसकी थोड़ी सी बड़ी, that is R4 R3 plus R4 1 plus R2 by R1 minus V1 R2 by R1. Then the diagram, positive terminal if term that is R2, इसमें इनकी नोटेशन है, नोटेशंस हैं उन्हीं के अकॉर्डिंग डू द चेंज द नोटेशन, मतलब R1 R2 को तुमने चेंज कर दिया, देन फॉर्मूला विल आल्सो चेंज, तो रिमेंबर इट लाइक दिस ओनली। जनरली डिफरेंस एम्पलीफायर मणिपाल में नहीं। ओके, लास्ट इज इंटीग्रेटर एंड डिफरेंशिएटर। Based on this, you will get one integrator and integrator. For integrator, output voltage is minus 1 by RC. Integrator है तो integration in of t, limit vary from 0 to t. For differentiator, V naught is equal to minus RC in by dt. So what is the difference? थोड़ा सा ही difference है. In integrator, we'll use capacitor as a feedback and input resistance as a input वाले केस के लिए this is V in, this is capacitor. But for differentiator we'll use input में capacitor and feedback में resistance. You can see it's a vice versa thing. Okay. Last but not least, next one is voltage comparator in opamp only. Voltage comparator, as you can see, it will provide two voltage. Like suppose this is positive, negative, this one is V in, this one is V reference, ठीक है. This one is plus VCC, this one is minus VCC. The output will have output voltage, so it would be out is equal to plus V saturated if V in is greater than V reference. ठीक है, इनकी वैल्यू ज़्यादा है तो आउटपुट क्या आएगी, प्लस आएगी, एंड अपोजिट है देन इन दैट केस माइनस आएगी. यही है इसमें यूनिट. ठीक है. नाउ आफ्टर दिस विल हैव स्क्वायर वेव जनरेटर. Square wave generator is negative, positive. Positive is connected resistance to this R1. You have to remember this diagram. Voltage back is R, is connected with capacitor, then grounded. Okay. This one is, you need to write it here, plus minus the saturate capacitor out. This is basically the circuit of square wave. Now I'll tell you the formula. किसमें क्या है? Is equal to R1 divided by R1 is equal to out. क्या की वैल्यू है, V2 की वैल्यू है, V out की वैल्यू है. From there you will get the V out value. Now V out is plus V saturation, मतलब प्लस आएगी वोल्टेज if is less than V, but if V1 is greater than V, then in that case you will get minus V saturation. ठीक है. Now sometime they'll ask you the time period also. So time period का will have formula 2 into RC log ln 1 plus beta divided by 1 minus beta. तो ये फॉर्मूलेस तुम्हें याद करने पड़ेंगे, देन यू विल बी एबल टू सॉल्व इट. स्क्वायर वेव जनरेटर का एक बार पढ़ लेना, फॉर्मूलेस याद करने, गेट डायरेक्ट फॉर्म. आई